Hello dear students, in this lesson we are going to learn basics of synchronization. Synchronization is a huge topic and we will learn it with you during multiple lessons. This is the first lesson about thread synchronization that will give you basic knowledge. When you create concurrent programs, one of the most important things that you should care about is the synchronized access of multiple threads to the critical areas. What is critical sections? We'll learn with you today in this lesson. Also, we'll learn with you concepts of monitor and mutex. After this lesson, you will understand these two concepts very well. I will explain you what is atomic operation and what is not. Once you'll understand all this theory, we'll jump to practical examples and we'll create our first program with synchronized threads. I will explain you how a synchronized keyword works with methods. And at the end of the lesson, I will explain such methods as await, notify, and notifyAll. All objects in Java have these methods. Let's start. To begin with, let's understand what a critical section is. It is important for us to learn this first, because the rest what we are going to do in this lesson is to synchronize access to critical sections. That's why understanding of this term is critically important. Imagine that you have multiple threads that are executed concurrently, and there is a block of code that is theoretically may be available simultaneously for two threads. This means that in some point of time, it might happen that two or more threads will interact with some resource simultaneously. That may cause mistakes in calculations and data inconsistency. In other words, critical section is a group of instructions that should be executed concurrently only by specific number of threads and performing specific operations. Usually it is one thread. But as we will keep learning multithreading to advanced level, you would understand that sometimes we wanna allow multiple threads to perform one operation with resource and allow multiple threads to perform another operation. For example, imagine that you have collection, let's say array list. Operation of adding new elements to array list should not allow other threads read value from any index. Add method should block access for all other threads to read elements from specific index. Because I can add new element in that position, and that would cause dirty read by other threads. At the same time, there is no need to block other threads in case all threads only read data from my array list and don't change its state. That's why I may allow as many threads as there exist to read data from array list only until moment of adding new elements to container will come. Does it make sense? Now let's understand what is an atomic operation. Atomic comes from Greek word atom, that literally means uncuttable. In computer science, atomic operation is the operation that is performed with single processing cycle. In other words, atomic operation is an uninterrupted operation. Let's understand this on example. Imagine that you perform an increment of your object's property and you wanna update its state. What do you think? Is this atomic operation? It is not. Why? Because you have to read value that is stored in the piece of memory dedicated to the class property variable first. After that, you need to perform an increment and add 1. After that, you need to store the result of addition in some place, and only after that you need to assign the result of increment to another variable, our class property. Is it clear? So even such simple operation at the first glance, like increment, is not atomic. But in this case, what is an atomic operation? In simple words, read and write operations are atomic. For example, assigning value to a variable is atomic operation. Reading value from array is atomic operation. Assigning value to array is an atomic operation too. Does it make sense? Also in Java, we have a special package that contains only types that execute not atomic operations by nature, but actually execute operations that looks like atomic. For example, you know that increment and addition is not atomic operation by itself, but atomic integer, for example, may perform addition of another value in synchronized manner to not allow any other thread interrupt execution of this operation. Later in this course, we will review with you Java util concurrent atomic package that contains such types to perform atomic operations. We did a great thing already. Now you know what is an atomic and non-atomic operations. Also you know what critical section is. Let's look at example now, so that you can understand the problem of performing non-atomic operations with multiple threads and why we need to synchronize access to critical section. I open non-synchronized increment file. Let's look at the main method here. And I will say you before we start that the code below is a spaghetti code because we don't use executors in this example. Considering the fact that by this moment in our course we don't know executors, I will show you this example with basic thread class and runnable interface that we all know. Later in this course I will show you another solution which is, in my opinion, more elegant. But I will show it to you once we'll learn executors topic. I create lists that will contain references to all my thread objects, because I am going to create 10,000 thread objects. Why I need so many thread objects? To be able to demo you issues that may happen in case we would perform non-atomic operation with multiple threads. Here I have for loop, and you can see that in condition I verify that I made 10,000 iterations. On each iteration I create new thread object with the following implementation of runnable interface. I increment my static int variable that is present in this class, and I will perform this increment 10,000 times. So what value will be here once all threads will perform increment 10,000 times? We'll look at the answer in a minute. After that, in loop, I add reference of this thread to the common list of threads. I need this to be able to request each thread to join main thread and make main thread wait until all other threads will be executed. And again, you need to see this code to feel relief later when you will start use executors, because you will understand how executors would simplify interaction with multiple threads. And in body of the loop, I start each thread. After that, in for each loop, I ask each thread to join main thread and make my main thread waiting until all other threads will be executed. When all threads did increment, we can print our variable to console, and let's see its state. I will run program multiple times to let you see the issue. Can you see that the result is not always 10,000? Do you understand why this is happening? That is because at some moment of time, two threads entered this method simultaneously, and both threads read the same value of counter variable, and each thread made increment. But logically, this is two increments, but in fact, one thread override increment result from other thread, and we got lost update. Is it clear now? And what to do and how to solve this issue? You already can easily spot where critical section is. We need to synchronize access of different threads to our critical section where we perform non-atomic operation. That's why I started lesson from explanation of critical sections and atomic operations, to make sure that by this moment of time in our lesson, you would understand what I'm talking about. Let's now try to solve this issue. To solve this issue, we need to control concurrent access to the critical area. The basic tool in JDK for this is Synchronized keyword. Let me open Synchronized increment class. This is similar example to the previous one with only one difference. My increment method has Synchronized keyword here. Let's run our program now multiple times. And you can see now that I constantly have 10,000 in console. That is because this synchronized keyword doesn't allow two threads access this block of code simultaneously. That's why we just eliminated all possible errors. How the synchronized keyword works? We need to understand this to create more complex solutions with better performance. To understand how synchronized keyword works, we need to understand such important concepts in multithreading programming as mutex and monitor. Let's start from understanding of what monitor is. And once we learned what a monitor is, I'll explain the difference between mutex and monitor. My own definition of monitor sounds like this. Monitor is a mechanism to synchronize threads' access to critical sections. More complex definition from Wikipedia also includes other properties of monitor, like ability to allow threads to have both mutual exclusion and the ability to wait for a critical condition. By the way, mutual exclusion is also a term from computer science and describes a property of concurrency control which should prevent a race condition by not allowing any thread entering critical section if some other thread currently executing code of critical section. Somewhere you may read another definition saying that monitor is a thread-safe class, object or module. That is partially also makes sense. We can use an object as a flag and as a monitor to indicate which thread captured the monitor of the object and which thread released monitor of the object. So in Java, monitor is implicitly associated with an object. Let me support my explanation with visualization. Let's look at the example with my car. Here is my Audi RS5 that can reach 60 miles per hour in less than 3.5 seconds. This has nothing in common with multithreading yet, but we'll jump to the details soon. Imagine that this car is a monitor, and critical sections here are accelerated pedal, brake pedal, steering wheel, and so on. I am a thread. And girlfriend of mine is another thread of execution. Two threads can't simultaneously interact with pedals. It will be a horrible thing in case me and girlfriend of mine will be pushing on different pedals simultaneously. I can capture monitor and do operations with the car that I need. I open the car and drive to an office, and when I got back home, I released monitor. When monitor is released, another thread, my girlfriend, can take it and can go to the beauty salon, for example. Is it clear so far? There are also some methods that allow to interact with monitor. They are wait, notify, and notifyAll. Wait method is overloaded and has versions with arguments. There are time-related arguments, milliseconds and nanoseconds. These methods inherited in all types from object class, because all objects in Java implicitly extend object class. What these methods do? Let's review an example. Imagine that my girlfriend took a car, and all of a sudden something happened with the car and it was stopped unexpectedly. She called me and asked me pick up her with the car and help. When I found her in the city, she went out of the car and let me in. What she did? She released monitor of the object temporarily and let me capture monitor. She still has intention to drive further, but she just let me also perform some actions with the car. That is exactly what wait method does. It just releases monitor and let other threads capture monitor. I was happy to discover that my girlfriend just didn't deactivate immobilizer and the engine appeared to be blocked. I fixed that and told her that she can drive further wherever she needs. What I did? I called notify method on the monitor. Notify method makes all threads that were waiting aware that they can proceed their work. That means we use wait method to let other threads perform some actions and modify the state of some objects if needed, of some shared resources. And after that, other threads should call notify method to update all threads that their work done. Another example of wait and notify. You're going to have coding exercises soon, and there will be a task about readers and writers. For example, readers interact with some buffer of memory, where readers should find information to read. Readers capture the monitor of buffer object and doesn't allow anyone to work with it. Once readers read all information from buffer and buffer is empty, they are turned into the waiting state and they wait until writer put new information into the buffer. Once writer finished its job and put all information in buffer, it notifies all readers that were in waiting state by calling notifyAll method on buffer object, and now readers continue read information from buffer and so on. NotifyAll is a method to notify not only one thread that is in waiting queue, but notifies all threads that are in waiting queue. Hope that now you understood what is a monitor. Now let's understand the difference between two terms, monitor and mutex. Conceptually, these two terms are similar. The only difference is how they implemented inside. Usually the implementation of monitors is faster, lightweight, since it is designed for multiple-threaded synchronization within the same process. Also, usually, it is provided by a framework library itself and not requesting the operating system. Usually, mutexes are provided by the operating system kernel. What is OS kernel? In simple words, it is a computer program at the core of the computer's operating system and has complete control over everything in the system. It also handles data processing instructions for the central processing unit. It is a portion of the operating system code that is always resident in memory. Usually, libraries, frameworks simply provide an interface to invoke mutex. This makes them heavyweight, slower, but allows us to achieve expected result to synchronize threads between each other.
A lock or mutex, for mutual exclusion, is a mechanism that enforces limits on access to a resource when there are many threads of execution. A lock is designed to enforce a mutual exclusion concurrency control policy. A monitor consists of a mutex lock object and condition variables. A condition variable essentially is a container of threads that are waiting for a certain condition. Monitors provide a mechanism for threads to temporarily give up exclusive access in order to wait for some condition to be met, before regaining exclusive access and resuming their task. So monitor is different than mutex, but they can be considered similar in the sense that monitor is built on top of mutex.
In this lesson I will use monitor term further, but just in case you will heard that somebody uses mutex term, you already know the difference. Now let's look at the coding example and we'll try to understand how monitor works, how synchronization happens, and practice example of wait notify interaction. Let's get back to synchronized examples that we already saw today. There is one more method here that is similar to synchronized one. Pay attention that this method doesn't have synchronized keyword in the same line with method name, but it contains synchronized block. What is this? So when you have synchronized method, it is fair to say that you captured monitor of this object which you used to invoke the method. But what object you used to invoke the method in this case? And also, how it works with static methods. With static methods, you capture monitor of this class. To create synchronized block, you have to pass the reference to an object where you wanna capture monitor. Right now, in this block may enter only one thread. And once the thread will leave this block, it will release monitor of this class. And the next thread will enter this block and will capture monitor of class. With synchronized methods, that principle is the same, but you just have synchronized access to the whole method, and not only for a specific part of it. Why you might want to use synchronized blocks? That is part of multithreading optimization, because it may be that actually not all lines in your methods is a critical section. Probably there are some operations that your multiple threads may perform in parallel. There might be really different cases. For example, here you want to print some text to console, or you just want to log that you entered this method and you want to log some message after critical section, or it can be some preparation activities before the operation. Anyway, logging printing text to console in this case is not a critical section. This will not bring you to inconsistent state of your system. That's why there is no need to make your threads wait to do operations that they can do now without waiting. So all code outside of the synchronized block may be executed concurrently. When you will create a multithreading program, always ask yourself, do I need to synchronize access to this chunk of code or no? What will happen if two threads will execute this code simultaneously? And in case you would discover that nothing bad would happen, do not put this code in synchronized block, because in this case, you would improve performance of your app by not making your threads waiting when they shouldn't be waiting. In general, this is rule of thumb, to have as small synchronized block as possible. In case this method won't be static, you will capture monitor of another object. In this case, you would capture monitor of this object, the one that invokes this method. So these two methods now are similar. What potential drawback you see in using synchronized blocks? With synchronized blocks, you can't capture monitor in one place and release it completely in another place. You can't describe synchronized block in multiple methods. But there is so-called log API that we are going to learn also in this course that will allow you to capture monitor in one place and release it somewhere else. Now let's look at waitNotify example. I grouped all classes related to this example in a separate package here with name waitNotify. Let me open demo file and we'll start from client code. Imagine that I have some message. I create object of this type and left some message to process it. Let's have a look at the source code of message type. Message has one property that describes its state. It is called message. I need this type for string processing because you already know that string itself immutable object. Once I create object of type string, I can't change its state. That's why I created separate type that has API that allows me to update the state of the same object. Also, there are two methods here, getter and setter. That's it. Let's get back to the demo file. The second object that I create here is reader object. I pass the reference to the message object via constructor. After that, I create thread object, pass reference to the reader there, and name a thread as reader1, and start a thread. Probably you already understand that reader implements runnable interface, and you are right. We'll review source code of reader type in a few seconds. Also I have another reader, and pay attention, I pass the same message object to the constructor. This would be exactly the object that I would use for multiple thread synchronization. Here I create another thread object with name reader2 and run this thread. So after this line we would have 3 threads running, my main thread and 2 readers threads. Let's learn what will be executed inside our readers in run method. As you can see, reader class implements runnable interface. It has one property. This is property of message type. Inside the run method, I get name of the thread for our demo purposes to print its name to console. And after that I have synchronized section. I didn't make synchronized method because in this case,
all reader objects would have separate monitor.
I need common monitor that is shared between 2 threads. This is additional advantage of synchronized block, because you can pass any object as a reference to capture monitor. And I have this message object that is shared between 2 waiters. So I capture monitor of message object. After that I print thread name to console and indicate that this thread is waiting to be notified and print current milliseconds. After that I call wait method on my message object. One more important thing. You can call wait method only in specific context. You can call this method only from synchronized sections and from synchronized methods. In case you would invoke wait method not in synchronized context, you will get runtime exception with name illegal monitor state exception, because thread is not an owner of a monitor. Once I call wait method, this thread is in waiting queue to proceed execution when it will be notified. At the same time, the second reader managed to enter this section. Considering the first reader called wait method on monitor, that means that monitor is not blocked and another reader can enter this section. Now it is time to learn what is happening next. Let's get back to our demo file. Now it's time to create a notifier object. Notify type is my custom type that I also described in this package. Pay attention that I pass the reference to the same message object. Create new thread with name notifier and start it. After that I print that all threads are started. Let's investigate what does notifier do. As you can see, objects of this type also will store the reference to the message object. This is our monitor. In run method we get name of the thread and indicate that this thread started its work. After that I make this thread sleep for 100 milliseconds. That is to ensure that reader objects captured monitor first. Once the thread waked up, I try to enter synchronized block. And until any other thread is capturing message monitor, all other threads, including this one, will stay right before the critical section and wouldn't enter it until get notified from the thread scheduler that monitor is released. You remember that in other threads we invoked wait method. That means that notifier may enter this section and capture monitor. In this critical section we perform message processing. We change the text to indicate which notifier updated the message. And after that I invoke either notify or notifyAll methods. In case I would invoke notify method, only one thread will be notified, either reader 1 or reader 2. Let's check this. I run demo file. Here is a notification about reader 1 thread started. Notifier thread started here, and reader 2 started and waiting to get notified here at this time. And once I called notify method, reader finished its execution. So now you can see that reader 1 got notified and reader 1 message processed. In the source code of reader class, you can see that I print this text to console after wait method at the end of run method. So after notification, all code that is below wait method got executed. Pay attention that our JVM isn't stopped yet. You can see the thread stop sign that tells us that I can stop JVM, but it is running. But why? Another reader thread is working now. It actually does nothing at the moment. It is just waiting to be notified in this line. But only we know that there are no threads left in the app right now that would be able to notify this reader object. All other threads, I mean main thread, reader 1 thread, notifier, already executed and finished. And this is the last thread that is waiting right now. Let me stop the JVM. If you know that such case may happen, in case you know that 2 or more threads may enter critical section and wait until being notified, you should think about your multithreading logic very carefully to avoid cases like this. One thread is waiting and there are no other threads to awake this thread. How to fix this? You should control how many times you call wait method and how many times you call notify method. Considering we have one point in our app where we call notify method in our single notifier thread, and we have 2 reader objects where we call wait method, let's invoke notifyAll method in our notifier. I open notifier class and will invoke notifyAll method instead simple notify method. Let's run our app one more time. Now you can see that all threads finished their work and no other threads running. We have both reader 1 and reader 2 notified. You can verify this by investigation of console output. Is it clear? It is great that now you know how to work with wait notify methods and synchronization basics. Let's recap what we have learned in this lesson. In this lesson we learned what critical section is. You understood what atomic and non-atomic operations are. And we are still going to learn with you Java util concurrent atomic package in the next lessons. So stay tuned. Now you know what monitor and mutex are and what is the difference between them. Also you know what is synchronized method and what is synchronized block. And at the end of the lesson we have learned what wait, notify and notifyAll methods are. That's all for today. Hope you enjoyed this lesson. Thank you for your attention. See you in the next lesson.